Lesson 6.1, Exponential Growth and Decay Functions. Our essential question, how do you graph exponential growth and decay functions? So first, what is the exponential function? That is the problem y equals a times b to the x power. And there is something that you need to remember about both a and b. So first, a cannot be 0. Because if a is 0, then you're multiplying by a 0, which meant everybody was just 0. So a cannot be 0 is the first item. Now b. B has to be a positive number, and it has to be a positive real number, and it cannot be 1. Now why can't it be 1? Because if you have 1 and you're raising it to any power, 1 to the second power would have been 1. 1 to the 10th power would have been 1. If you have 1 to any number, all you're ever going to get is 1. So it's not going anywhere if it is actually 1. That is why it needs to be something other than 1. And we have two exponential functions. You have an exponential growth function and you have an exponential decay function. What is the difference? In an exponential growth function, your a is going to be greater than 0 and your b is going to be bigger than 1. Since it's bigger than 1, you are growing. That's why it's a growth factor. So this is our growth factor. Well, what about exponential decay? Your a still needs to be bigger than 0. This a always needs to be bigger than 0. Now, our b needs to be between 0 and 1. Remember, because it had to be other than 1, and it needs to be positive. It could not get negative, but if it's smaller than 1, that means it's decaying, it's decreasing. Then this would have been called the decay factor. A is always going to be bigger than 0. Your b. If your b is bigger than 1, that means you're growing faster than normal. If your b is smaller than 1, that means you're not growing, you're actually decaying. And these are the visuals. If you were in exponential growth, you are growing, and that's because you had your b bigger than 1. You are decaying, you are going down, and that's because you were smaller than 1. Remembering, they always have to be positive numbers. So let's go ahead and look at graphing exponential growth and decay functions. We need to tell whether the function represents growth or decay, and then they want us to graph it. And we're going to graph it using a table. So first thing we do is we identify the value of b. Why is that important? If you remember from our previous video, b was the difference between growth and decay. How do you identify b? B is the value that has the exponent immediately connected to it. So we're going to look for b, because b will tell whether we're growth or with decay, and you find b by looking for the exponent. So here's my exponent. I identify that my b is 2. Since my b is greater than 1, I know that I have an exponential growth because it's going at a rate bigger than 1. Now I need to graph it, which means I need to use my table to figure out what my other values are. I'm going to plug in -2 for the x value on my calculator, and I get the fraction 1/4. Plug in -1 to the x value on my calculator, I get the fraction 1/2. Continuing by plugging these values into the x value on my calculator, I get 1, 2, 4, and 8. The last step in graphing this is to plot the points that you have, so plot your table. I see my x's do go negative, my y's do not go negative. So I am going to do an x-axis that has both positives and negatives, but my y-axis only has positives. I'm going to count by ones, and I'm going to plot my points. And we're going to connect it with a smooth, curved line. Now we thought growth. It is growing as we read it from left to right, so we are correct. This is an exponential growth graph. Our next problem, we have a new y function. We are asked to identify whether it represents a growth or decay, and then we're going to graph it. So for growth or decay, the first thing you always need to do is you need to identify b. B is the value that had x as the exponent, so my b must be a 1/2. And since this is between 0 and 1, that meant that this was an exponential decay. So when I graph this, I should be decaying. I should be going down. So let's go ahead and do that. I have my table of x values. I'm going to plug those x's into the x value and see what my y's are. When I do that, -3 gave me 8, -2 gave me 4, -1 gave me 2, 0, 1, 1, 1/2, 2, 1/4. My x's are positives and negatives, but my y's are only positives. So I'm going to have both sides of the x-axis, but only the positive side of the y-axis. I'm going to go ahead, I'm going to count my axes. -3, 8. And connect with a smooth U shape, or a smooth curve. And I see I am decaying. So I graphed it and I represented my decay. There are 3 problems left on the page for independent practice. Please do these 3 problems on your own.